My name is Melissa Bube, but I go by B. I'm a software engineer at a company called Inmar in Winston-Salem, North Carolina. And I've been there for about 7.5 years. And you may wonder, as a software engineer, why am I here talking to you about ethics and algorithms? So this started out about 1.5 years ago. I was at CodeStock in Knoxville, Tennessee, and I was really struck by a lot of the talks on AI and machine learning at that particular conference, particularly when it came to the opening keynote that was done by Paige Bailey. At the time, she was a developer advocate at Microsoft. She has since moved on to Google, but her expertise is in AI and machine learning, and she got me really excited about the idea of all of these financial institutions using different algorithms when it came to applying, people applying to different loans and mortgages, as well as exciting things that we could do from handling a natural disaster perspective. And it really made me start thinking about a lot of people at these different conferences, as well as a lot of people who are listening to what their board members are saying and really looking at like what's in this airline magazine while I'm riding this plane, are really hyped about incorporating AI and machine learning into all of our products where we're all working today. But nobody was really talking about how we can make sure that in our profession, we are being ethical about how we create and apply those algorithms. And as I started to ask more of those questions, I don't know if you guys have heard this when you've asked questions at work, but they're like, why don't you make that talk? So that's why I'm here today to speak about ethics and algorithms. As a general overview, I'm going to talk a little bit about how ethics and algorithms are kind of spoken about in the media today, both the concerns and vulnerabilities that can be out there, as well as how they're being utilized in really exciting ways. Full disclosure, this does have a very kind of Western slant to it. A lot of the examples I have are largely from the United States, Canada, the United Kingdom, and Australia, as opposed to places outside of that. So just in terms of full transparency, that's where a lot of these examples are coming from. And I'll also talk about some of the things that I was able to research into what we're able to do, not just as an entire community, but as individuals, as we're working on these types of things, and maybe as our companies are asking us to incorporate more AI and machine learning into what we're doing on a day-to-day basis. Who here is a software developer or engineer? Okay, so the majority of people. Is anyone getting pressure to start bringing more AI and machine learning into the types of products that you're creating? Yeah. So hopefully this will give you some ideas on how we can keep ourselves accountable and things that we can do to really have a positive way of applying all of this work as we move forward. So let's start with talking about the media. And start off with talking about self-driving cars. Who is familiar with the trolley problem? Almost everybody? I'll give a quick overview for people who aren't familiar. Here's a picture from The Good Place for people who may or may not be familiar with the show. Generally speaking, the trolley problem is a thought experiment in philosophy where you're on this runaway trolley. You essentially have no control over it, only one thing. And if you do nothing to deal with this runaway trolley that you're on, you will run over 5 people and kill them. The only control that you have is over a switch that will allow you to switch between the tracks that you're on. And if you switch tracks, instead of killing 5 people, you will kill 1 person. So there are different twists on this thought experiment that people have applied. So a lot of times from a utilitarian perspective, people will say, I'll kill 1 person instead of killing 5 people. I have no other options because this is a thought experiment. But would your answer change if the 1 person was a child and the 5 people were 85-year-olds? Would your answer change if the one person were a loved one of yours? So I bring up the trolley problem because a lot of people have brought it up when talking about self-driving cars and raising questions about who's making decisions about the types of choices that self-driving cars make on the road, and how does that kind of get applied as these continue to grow as something that's a really viable transportation option. So, like, just as a general example, when I was in driver's ed, we learned that if you're on the highway and an animal runs in front of you, you run that animal over because it is the safest thing that you can do. Most people I know are not going to just like run down that animal. But if we're talking about by the book, what is the safest thing to do? What should I instruct this vehicle to do that's making decisions? Maybe that's a decision it would make. People start to get thoughtful when a car is making decisions about who should live and die. If it's going to save 15 people, should a car protect its occupant, even if there's only one, or should it protect the people on the road? A lot of interesting questions come out of this. And going back to a brief side note that I had mentioned with the trolley problem, is it a number of people thing? Is it the content of who those people are and what they represent? And it's interesting not just what is put forth from like a ethics department perspective, but also what's put forth in terms of what surveyed people's responses are. So a year or two ago, Popular Mechanics put out a survey, and out of 2 million people, most prefer that a self-driving car kill the elderly. But I mean, only if it had to. So there are definitely a lot of thoughts around how these decisions should be made when we're applying these algorithms in life and death situations. Another concern that comes up when we're talking about how these algorithms are being applied has to do with both the data that comes in and how we train our models, but also has to do with some of the technological limitations that we have or the limitations that come from time of day. So in particular here, I'm talking about computer vision and how much light we have and the training data sets that we use to train algorithms on whether someone is a pedestrian or not. I don't know if anyone has seen Better Off Ted, but this is from 2012. Essentially, it has been a problem for a very long time, and it is only marginally improving over time, that when it comes to computer vision, detecting dark-skinned pedestrians is very difficult. And when manufacturers that are working on creating these self-driving cars have been questioned by researchers, they have kept their approaches very black box. And so all that researchers have been able to do is base their assumptions off of what is available. And based on the training sets that are available in terms of easily accessible without completely creating your own data sets, and based off of the limitations that come from cameras today and various levels of lighting, when it comes to digging into that, the Georgia Institute of Technology found that there are still many, many concerns about difficulty in detecting pedestrians that have darker skin. And so, like I said, potential flaws in training vision systems. This is a black box sort of environment. If we don't have a way to look at what our concerns are and identify them and start digging into them, looking at these data sets, the problem that we have if we ignore it is that we can't go in and counterweight it. Because if we know that this is an issue in our data or an issue in how we're training things, then we can go in and find ways to ameliorate the issue. So let's go ahead and move from self-driving cars to policing. So this is another place where we heavily use facial recognition. So we have some of the similar problems here to do with training data sets and determining how we want to weight that data. Definitely a lot of the same limitations when it comes to transparency. But let's step away from facial recognition for a moment. So one way that AI and machine learning is utilized in policing, particularly when it comes to the United Kingdom and the United States, has to do with bail and sentencing, as well as parole. So some local governments have essentially taken their historical data on how they've applied bail and sentencing and who has received parole versus who has been denied parole, and are using that to automate and determine who gets parole or not. And there have been cases where people have been denied parole by an algorithm and have brought court cases where their request has been denied on more transparency into why they were denied parole, because the judge determined that it was enough to know that an algorithm did it. So this sheds a little light on why education of everyday citizens, and particularly citizens that hold power like judges, can be very, very important so that everyone understands what it actually means that an algorithm did it. Just because there's math involved doesn't mean it's unassailable, but not everybody understands that. Let's go ahead and circle back to facial recognition and talk a little bit about banking. So at the end of last year, the National Australia Bank put out some information about how they designed this really exciting proof of concept where you can withdraw money from an ATM with a combination of a PIN and facial recognition. So as facial recognition becomes more and more utilized with our phones and in many other places, it is being cross-applied all kinds of places where people want some sort of biometric security. So this is being applied in ways that personally I wouldn't have necessarily expected to be able to like just pull my money out with my face. So I had alluded earlier to the application of AI and machine learning to mortgage and loan applications. So this is a place where, again, historical data is being utilized so that we can say, these are the people who have had loans and mortgages approved before. Here are people who we have denied. Let's take data about this person who is applying and just put them through the system and have an answer get spit out. What we start to run into here is that in the news well before AI and machine learning were like a hot topic, when all of these processes were manual, there was still a lot of concern when it came to processes like these, when it came to particularly racial bias. And when we feed in historical data where it's possible that racial bias was being applied, we run the risk of either perpetuating it or even magnifying it as we encode that in an algorithm. So people will do things like remove racial information from the data, which sounds great. However, there is such a thing as proxy discrimination, which has to do with I might really, really need zip code as part of my data for processing whether someone is eligible for a mortgage. However, zip code is highly predictive of someone's race because even today, throughout the majority of the United States, neighborhoods are still relatively segregated. And so if I'm leaving zip code in my data and I'm not doing other things to identify and ensure that my algorithm isn't using that as a crutch to kind of make racial assumptions based off of historical data, then again, I am either perpetuating that problem or even magnifying it. So fraud detection is another area where we've been seeing different algorithms being applied for a long time. Who has had their credit card automatically shut off because you made some weird purchase? Who has had to catch on your statement that something weird happened because your bank didn't actually catch it? So obviously there's still some things to work out when it comes to fraud detection, but obviously this is a place where AI and machine learning are continuing to be applied so that we can automatically find issues as they crop up. So the other place that I didn't necessarily expect AI and machine learning to be applied in banking has to do with personalization and natural language querying. So the Narrative Science and National Business Research Institute surveyed a large number of financial services executives, of which 32% said they were applying some kind of artificial intelligence to their products, particularly when it came to predictive analytics, recommendation engines, voice recognition and response, and overall personalization. So this largely has to do with things like taking data on one of your clients and giving them personalized investment advice based off of your personalization algorithms. Or it has to do with, I'm not going to pay someone to answer the phone anymore. I'm going to put together an automated phone system, and I want to make sure that A, I can understand what people are saying to me, and B, when they ask a frequently asked question, I'm answering the correct thing. So these are largely the places that banks are saying that they're applying a lot of AI and machine learning. So another general area where AI and machine learning has been in the news within the past year has to do with hiring. So is anyone involved in the hiring processes at their companies? Hiring is hard, right? Not only is it difficult to find and track the applicants that you want, but it's difficult when you are inundated with resumes to narrow that resume pool down. So finding ways to streamline that process is really, really appealing. What you may have experienced is that the processes that we have manually today are A, not well documented, or B, are very feely, yes, I feel that this candidate is good, and aren't necessarily based in specific verifiable facts that you could feed into a machine. But this is definitely one of the places that people are the hungriest to apply AI and machine learning so that they can streamline this and make it a much quicker process, and so that they can identify candidates that aren't going to have high turnover. What we found is that as people have applied this within particularly large and visible companies, that we've had pretty disparate sort of responses. So at Amazon, we've seen that they had been applying a proof of concept and they had to kill it because it was only putting through men's resumes. And even when they were aware of that and tried to ameliorate it, they weren't able to find success, and so they killed that program. On the flip side, we've seen that at LinkedIn, they are hyped about using AI to make recruiting more diverse, and they said that they have found the answer and made it really, really easy to find diverse candidates through LinkedIn. Now, of course, this is them kind of self-reporting, but it's interesting the dichotomy there as people are trying to use very similar data to come up with recruiting type results. Circling back to transportation a little bit, let's talk about Boeing. So Boeing has been in the news a lot, particularly this year. And what may or may not be obvious about the difficulties that they've been having with the 737 MAX is that not only were updates applied to the autopiloting system from an AI perspective, but those updates were not communicated in the piloting manual, they were not communicated to the pilots in any way, and they were not overwritable. And so when sensors failed without backups, pilots didn't understand what was happening and were having to fight the AI in order to try to cope with how it was inappropriately reacting to the situation at hand. This is definitely an example of where transparency, at least internally, is really, really important because it allows people to have the information they need to respond to the situation in the way that they can. It's also an important example of why manual overrides can be really, really valuable and why in self-driving cars, for example, there are definitely many manual overrides today because of these types of concerns. So because AI and machine learning are in the news a lot, reporters for some of the top newspapers and magazines are just really interested in, like, maybe I could apply AI and machine learning in this kind of realm and let me recommend to everybody how this is a good way to apply these types of technologies. And this came up within the past couple years when it comes to predicting mass shootings. So in the New York Times, they put out an article about how they had identified that mass shootings in the United States are very, very highly correlated with coming immediately after a giant spending spree on a credit card. So there's a really strong correlation with financial activity. So in case it is not clear, while truly, truly terrible, mass shootings are very rare. And in these types of situations, when we are trying to predict something that is very rare, we run into issues that we don't necessarily run into in these other situations that we've been talking about. Because even the tiniest of inaccuracies can cause really large problems. Let's go through a theoretical example. This is going to be very theoretical because we don't have very clear and accurate statistics on how many guns are sold in the United States every year. We can kind of try to extrapolate information from when background checks are run and how many, as well as ATF information on how many guns are manufactured in the United States that are not manufactured for the military. But from there, we have numbers from 11 million to 25 million. It's not very clear how many guns are really sold in the United States every year. We do know that there are over 300 mass shootings in the United States every year. But for whole numbers and for just a theoretical example, let's say that 1 in 1 million high-dollar gun purchases precede a mass killing. And let's try to visualize what 1 million means. And I had a lot of problems trying to figure out how to visualize this together, but I found this website that will let you scroll through 1 million dots. So we're gonna look at this real quick. So you might not be able to tell, but we're starting to scroll through this, and on the side, for every 100,000, you'll see a number. And we're actively scrolling, and this is going to take a full 17 seconds to scroll through these 1 million dots. So let's say that our detection algorithm is 99% accurate. If it's 99% accurate, about 10,000 of our 1 million purchases are flagged as potential mass shooters. So here's our 10,000 dots out of that 1 million. But only one of those indicates an actual mass shooter. So that's 9,999 false alarms, where if we were actually to apply this kind of approach to identifying mass shootings, we would be spending resources and time and fear on 9,999 false alarms. So again, this is an example where people can get really excited about how we can apply things to identify stuff that we're concerned about. But if we're in a situation where essentially it is a very rare occurrence, there are more things to take into account than we would necessarily be taking into account in other situations. But let's talk about something a little happier. So one of the things that really hyped me up about, like, even just thinking about ethics and AI and machine learning in the first place was, again, Paige's keynote at Codestock last year, where she's talking about how we can apply AI and machine learning to disaster relief. So there are multiple problems when it comes to dealing with disaster relief. One of those problems is that there are dozens, if not hundreds, of non-government organizations or NGOs that are all trying to help at the same time. And they can have a lot of difficulty coordinating with one another. So one of the open source projects that's out there has been really working hard to provide ways for coordination between these NGOs so that the areas of largest concern and the areas where help is needed the most are identified and people can coordinate in a way that's very effective. Additionally, what happens in a lot of disasters, natural and otherwise, is that the 911 system becomes overwhelmed. And if someone tries to call in, they can't. So another thing that has been actively worked on when it comes to machine learning has to do with quote unquote next gen 911. So that when people are calling in, they have a way to be routed to what they need and only routed to a real person if that is what's actually needed. And so the manpower that's needed when staffing any of these issues when it comes to these huge disasters is mitigated by a machine learning system that can help answer these calls and route them appropriately. So I got just really excited about how we can help care for disaster relief. But all of these examples that we've gone through so far have to do with things that are kind of inherently coming into these due to our data or due to how we trained our algorithms. And we haven't talked about adversarial attacks. So let's circle back to self-driving cars and talk about the Tesla Model S. So about 2.5 years ago, researchers took the Tesla Model S and they were like, self-driving car, let's see what I can do with this. And they were able to run the Tesla Model S into oncoming traffic with 3 stickers. And essentially what they did was they realized that based on the way the Tesla Model S was identifying what its lane was and how to switch lanes and that sort of thing, they could lay down 3 stickers in a row that appeared to be related to a lane and direct that car into oncoming traffic. Again, with self-driving cars, researchers have gone in and said, can I fool this self-driving car into thinking that this stop sign is not a real stop sign? And at the same time, can I make sure that the human doesn't realize that the stop sign has been fiddled with? So all 3 of these stop sign images can fool a self-driving car into thinking that it is either a speed limit sign or is just generally not a stop sign. The darker image essentially is a stop sign that has some discoloration on it. Stop signs are dirty all the time. It's not particularly noticeable to the human eye that there's something wrong there. We see graffiti on stop signs all the time. It's not something that's surprising. So just by putting these slight perturbations onto the actual stop sign, we're able to fool these cars into not stopping and potentially causing a hazard. But self-driving cars aren't the only place where researchers have identified a high risk of adversarial attacks. Another area has to do with medical fraud. So if we're talking about computer vision, again, we can talk about things like introducing perturbation into the image. So the original image was a completely benign mole, and then noise was introduced into the image that, when applied to the image, is not visible to the human eye. But the algorithm that determined that the original mole was not cancerous identified the mole as cancerous after that noise had been introduced. What I find, go ahead.
Was that noise random, or just they made a particular attack pattern?
It was a particular attack. What I find particularly interesting is that not only do we have these images that we can introduce noise into, but even minor modifications to the text medical record of a patient can have surprising effects. So the one that I was reading up on had to do with if I change the language on a medical record from saying that someone is dealing with alcohol abuse to saying that someone is dealing with an alcohol dependency can change whether the system is saying that it is safe for me to prescribe that patient with an opioid, just by that one word change. And to me, like, those sound like the same thing. But in terms of the word association that is being utilized, the outcome is completely different. Going back to images, Google image identification is something that people have been fiddling with for a long time to like figure out if they can mess with it. And scientists were able to do things like identify these skiers as a dog, or identify this turtle as a rifle. I mean, this is a very scary turtle, guys.
If you buy a turtle, there's sure going to be a master attack.
But again, it's not just images that can be fiddled with. Anything that requires input from outside of it can be modified to an extreme. And obviously, a really clean example of this are Twitter bots. So let's see, what happened to Microsoft's Twitter bot in less than a day of being on Twitter? My favorite. So in the time that we have remaining, let's talk about what we can do, both as a community and as individuals, to care for some of the concerns that we have when it comes to applying AI and machine learning in our work. So from a community perspective, first off, we can amplify things that are already out there. If we see a practice that we're like, this is what we need to continue to have in the community, we can make sure that we're yelling about it as much as possible. This is awesome! And that we copy it. This is a good thing, I'm gonna do it too. Ooh. We can reframe our conversation. So obviously, we all work for companies that are trying to make money, and a lot of times the conversation is about accuracy and money. But it can be very helpful to reframe the conversation to make sure that we talk about inclusion and equality and don't completely ignore those, because merely including those in the conversation has a significant impact on the outcomes. We can also work on broadening the conversation overall. We want to include more people, like we said when we're talking about reframing. We can truly include them by making sure that it's not just me and my little group at work and we're like talking about maybe there's something up here, but having a big conversation about let's be ethical when we create our algorithms and are making sure that when we're training them, we're thinking about things that we consider to be important. I alluded to this earlier, but education is a big piece of what we can do as a community. We were talking about these judges who are like, knowing it's an algorithm is all you need to know about why you were denied parole. Maybe if everyone who is involved in those situations had more education about what really went into these algorithms and kind of how they work on a general scale, they would be able to make clear decisions even without 100% transparency into the actual code. Because obviously, a lot of companies are concerned about their intellectual property. They don't want to expose the inner workings. But Microsoft and Google and Amazon have all been trying to find ways where they can provide a certain level of transparency about decisions that are being made and give broad reasons about why a decision was made without necessarily giving full transparency into the code base. So these are certainly things that can be done, and education can be applied so that people are more aware of how these work. And finally, we can expand the conversation and break silos. So I was actually thinking about this on Wednesday. I came in early for Code on the Beach. I went to the Women in Technology meetup on Wednesday night. And the thing that surprised me the most about that meetup was that there were 3 or more women's organizations that had come together to have that meetup, and that had virtually identical goals and missions, but had kind of been independently invented and kind of grown up independently from one another, even in the same geographic area. And this can happen a lot when people think that they're the only ones who have a particular concern. So the more that we can expand out and break down silos, we can take advantage of adjacent things like maybe I am talking to my friends who are working in security engineering, and they're like, you know what you could really do here is you could apply red teaming to what you're doing. So the more that we break down these silos, the more that we can learn from one another instead of having to independently invent the same thing over and over again. So what can we do as individuals? A very simple thing that we can do that sounds kind of silly because it sounds like a no-brainer is that we can share our questions and concerns. So this is something that no one's gonna listen to me if I bring up this concern, or what are they gonna do? But I have an example from just a couple months ago at my own company that's less to do with ethics and algorithms and a little more to do with accessibility. We have an internal newsletter, and more recently, instead of having text information, we have a picture of text or a blurry picture of text. And not only is that overall just an accessibility concern, but it's a heavy accessibility concern because we have a number of people who have vision impairments. And so without some kind of alternative text to explain whatever the image was going to have in it, they just have no way of understanding what was supposed to be put forth in the newsletter. So I reached out to our communications department and asked them if they were aware of this concern and if they could look into ways to either, on our videos, either create a transcript or provide closed captioning, and on these images, either just go ahead and provide the text or at least provide alt text so that people can understand what's going on there. Or even me with my moderate vision impairment, I can't tell what's going on in this fuzzy image. I would really like to know what you're trying to announce. And to my surprise, within an hour, communications got back to me and was like, that's a great idea. We already have people on making sure that when we have text, we're supplying that. And we're looking into resources of how we can make sure that on videos we have either closed captioning or transcripts, though that will take a little longer because there is a financial aspect of that. I didn't necessarily expect me just asking a question to turn into actual action, but fortunately it did. So again, we can share our questions and concerns, but also we can make sure that we're actively looking for that bias. So Microsoft has put out a lot of white papers when it comes to applying ethics when utilizing AI and machine learning. And one of the things that they noted is that a challenge with algorithmic fairness is that one usually has to know the potential group or groups that an algorithm might discriminate against in the first place in order to aim for that fairness. So if we're actively looking for bias, that will help us identify those places before we have entrenched some kind of unfairness into our system. So whether it's during backlog refinement sessions or during code reviews, we can make it part of our process to ask particular questions and check off certain steps so that we have satisfied our own due diligence on actively looking for bias and working to ameliorate it. Did you have a question? Okay. Finally, we can hold ourselves accountable. Like, that's kind of the point of this whole presentation, is that it's important for us to introspect about this and hold ourselves accountable to actually take action if we find something that's going on, or to take action to continue to make sure that we keep asking these types of questions. Obviously, there are multiple levels of holding ourselves accountable. You can go all in and like found an ethics board at your company. That's pretty intense though. You can, like I mentioned, put in some of those basic bias checks at various points in your software development life cycle. You can, if you have the time and monetary investment available to you, do something that's kind of exciting and interesting, like creating an adversarial algorithm to see if it can tease out any concerns about the main algorithm that you've created. And then you can even just, kind of going back to what we were talking about with hiring, you can better document and just generally improve the manual processes that you have today, so that if and when those are enshrined in some sort of algorithmic process, it is better than the process that you have today. So to recap, obviously AI and machine learning are continuing to expand in their application for a number of reasons. Our current state is that sometimes the way that's happening is a little grim and overwhelming, but sometimes it's exciting and hopeful because we're making sure that people who are dealing with disasters are getting the aid that they need, for example. But we can make a positive impact, both as individuals and as a community. So thank you guys for coming today. I appreciate your attendance. And I'm here for any feedback if we have questions right now. And you can always contact me directly via email. Are there any questions?
So I think, to me, what worries me most about the AI algorithms is you're taking a process we've got many, it's like chimpanzees trying to type Shakespeare. Everyone's got their own perspective, or Churchill's quote, Americans always get right after they've done every other wrong way. Someone's going to find the right way. But when you make an AI algorithm out of something like driving a car, on the road now, you've got hundreds of people making independently, and they're making their own decisions. But by centralizing it, you've got one thing making decisions. And I think that's what worries me greatly about any of these AIs, even on the idea of resources and distributing natural disasters. If resources are abundant and it's just human inefficiency getting out, that's fine, but it'd still be the trolley situation in just that alone. Who gets the water, who gets the food, who gets the blankets? We only have so much, we have to choose. Do you think there's a possibility of the AI eventually, AI's becoming to the point where individuals can just reprogram to say, in my car, I want to kill some elderly people and save a baby, or other people saying, no, the baby, no. If I have to choose on the trolley situation, going through a really grim questionnaire, is it eventually going to get to that point where it goes from a central authority back to a decentralized choice in how these things happen? It just seems, just the centralization.
Yeah,
Just
like
so
so you're saying that there are concerns about the lack of the ability to manually override on an individual scale?
Right. As you centralize things, what do you do with the exceptions?
Right.
Why can't people make their own choices about these exceptions if everything is in a black box as it would be in ML?
Yeah, people are definitely thinking about those types of questions, both when it comes to doing research and when it comes to even like science fiction. For anyone who is familiar with Cory Doctorow, he created an interactive short story which is kind of a spoof on the trolley problem, but it addresses what you were talking about when it comes to individual manual overrides and what happens when there's an adversarial attack on that central authority.
But just the fact that without intentionally creating these biases, awareness is really important. I mean, we also need to acknowledge the unconscious bias we all have. Forget AI for a second. unconsciously we're all biased in some ways.
Right.
Just awareness of that fact is important to bring that to the forefront and say, okay, let me do this check before I get into this room for this issue. Am I judging this candidate based on all the things that are all the things that are
Right.
Just that fact is important. And when we are designing these algorithms, let's also not just transfer the current problems into the newer problems. For example, the FICO score we all are very familiar with. What most might not know is that the FICO score doesn't account if an individual has been renting for 10 years and paying that rent every single month on time. That's not computed in the FICO score. Whereas a homeowner is computed. So these are societal biases that were there for a very long time. If you're working on those kinds of things, it might be important to go back and see, why was this FICA designed that way? Instead of simply saying, this is the FICA, I'm going to modernize it, right? Just, awareness is really important in this aspect. More and more, we are definitely in a mode where we are losing more and more of our computer.
Right. And to try to recap that so more people can hear, when it comes to biases, there aren't just conscious biases, but there are our own unconscious biases that we'll want to be on the lookout for and really be thinking about taking into account, as well as societal biases when it comes to the design of things, including, like in this example, a FICO score, and whether it is biased towards people who own a house and have a mortgage versus people who are renting, which may not be actually even factored into the FICO score, even if they've been very responsible with how they pay for their rent. Any other questions or comments before we wrap up? All right, well, thanks so much, everybody.